Welcome to this course on Python for Data Science. My name is Aaron and I am a third year computer science student from Adishankara Institute of Engineering and Technology, Kaladi. My basic interested fields are machine learning and data science, and I also worked on many machine learning and data science projects. So now let's don't waste any time. Let's move on to what is data science. So before going more deep, I will give a brief introduction about what is data science. Data science is basically the science of analyzing a raw data. And after analyzing this raw data, you have to derive insights from this data. You can use multiple techniques to derive insights. You can use a simple sophisticated techniques, or you can use more complicated and more sophisticated techniques like of machine learning techniques to derive insights. Nothing less. The key focus of data science is actually deriving these insights using whatever techniques that you want to use. Now, there's a lot of excitement about data science that we will be covering in the next slides. So, in this session, we are going to be mainly focusing on tools that are required for data preprocessing and analysis, and also some Python commands also. Now, currently there are many tools that are being used in data science. Now these tools can be buckled into three categories. The first category is where we are going to be looking at, that is data preprocessing and analysis. Now, tools and softwares that fall under this category are Python, R, MS Excel, SAS and SPSS. Now, all these tools are required for you to preprocess and analyze the data. So apart from data preprocessing and analysis, there is a fair share of effort that is given for data exploration and visualization. Now, the commonly used data exploration and visualization tools are Tableau, QlikView, and of course, you have your own MS Excel. So the next bucket that we are going to look into is when you have huge amount of data, example a big data, large amount of data. So when you are collecting that data on a real time basis, you are going to be collecting data over every second, every minute, every hour, every single minute of that data. Now, if you want to store all this data and preprocess it, the regular desktop or computing systems, that you might not be very useful. So that is when you are using parallel or distributed computing, where you distribute the work across different systems. Popular tools are being used for big data: Apache Spark and Apache Hadoop. So, in this session, we are going to be mainly focusing on tools that are required for data preprocessing and analysis, and also some Python commands also. We will be using Python as a programming language to do machine learning and data science programs. So why Python? That's a big question. Now let me tell a few advantages of why we should use Python. So Python has a feature that make it well suited for data science. So let us look at what these features are. So the first and the foremost feature of Python is that it is an open source tool, and Python community provides immense support and development to its users. So Python was developed under the open source initiative, approved, licensed, thereby making it as a free to use and distribute, even it for commercial purposes also. The next feature is that the syntax that Python use is fairly simple to understand and code. This breaks all kinds of programming barriers if you are going to switch to a newer programming language. So the next important advantage of using Python is that the libraries which are contained in Python gets installed at the time of installation, and these libraries are designed keeping in mind specific data science tasks and activities. Python also integrates well with most of the cloud platform service providers. This is a huge advantage if you are looking to use big data. So if you are going to download Python from a website and install it, you will see the most of the scripting is done in shell. So there are applications that provide better graphical user interface for the end users, and these are taken care by the integrated development environment, that is IDE. So let us see what are the commonly used IDEs for Python. The most frequently used are Spider, Jupyter Notebook, and Atom. And these are basically from the endpoint of the user depending on what he or she is comfortable with. Now, let us look on how to name variables and some of the common rules and conventions in naming a variable. So, you can see variables can be named alphanumerically. So, if I have a variable called age whose age is 55, then I can either have the entire age in lowercase, or I can also begin with an uppercase. We can also add a number 2. Wait, so let us say if I am creating another variable called age2, then I can add the number after the alphabets. So one thing that you should have noticed here is that the first letter should always begin with an alphabet, but however, if you were to begin with the number of the compiler throws an error saying invalid syntax. From this example, you can see I have started with a number, let's say 2 age equal to 55. It has shown a syntax error. If you want to assign multiple values to a variable, you can create all the variables at once and sequentially assign the value. Now, if you run this command, you will see that the values of variables chemistry, mathematics, and physics have been assigned accordingly. Now, let's look at the commonly used data types in Python. So the basic data types are Boolean, which represents two values of logic and are associated with conditional statement. So the output values that you would get when you use a Boolean data type is true or false, and it is represented as bool. The next type is integer. It consists of set of all integers which are positive or negative, the whole numbers. It is represented by the letters int. The next data type is complex, which contains real and imaginary part. So any expression of the form a plus ib is of a complex data type. It consists of all complex numbers and it is represented by complex. Now, float data type consists of all real numbers which are of floating point numbers. It is represented by float. String data type consists of all strings and characters. So anything that is enclosed between single or double quotes is treated as a single data type. The value that is enclosed between quotes can be numbered, a number or a specific character, or an alphabet, anything. So anything that is contained within quotes is treated as a string data type. It is represented by the letters string, str. So let's go further and see how to identify the data type of an object. Now, to find the data type of an object, you will be using a function type and give the object as an input. Now, an object can be a variable, can be any of the data structures, it can be an array or anything. In this case, in particular, we are just going to look at how to find the data type of variables. Now, let us take a small example. I have three variables here. The first is the contributor name, which is the name of the contributor and its value is Divjot. Let's say a variable age, represented by the variable name age, the value for which it is 55. The third variable is height, which is the height whose value is 150.6. Now, if you want to check the data type of a given type of contributor, now contributor is a string because it is enclosed between the double quotes. If you give the type of age is an integer, and hence the output is int. And if you give type of height, which is a floating point number, that the data type is float. So till now we have been seen how to find the data type of an object. We have also seen how to verify if an object has a desired data type. Now we are going to look at how to coerce object to a new data type. Now if I want to convert the data type of an object to another, I will be using the data type you need to replace data type with the abbreviation used for each of the data types, and you give the object as the input here. Now all the changes that have been made to the variables can be stored in the same variable or different variable. Now in this case, height is of a float data type. Let us say I want to convert it into an integer data type. So I say int height, which converts it into an integer data type. But if I want to these changes to be reflected in my environment, I have to store it on to a variable. Now the variable can have the same name or a different name. So in this case I am converting height to an integer data type, and I am storing it into a new variable called ht. Now if I get the type of ht, the output is int, which means height has been converted to an integer data type. Now if I want to reflect the changes of the same variable name, I will just say height equal to int height. So earlier the height was float, and now the operation is done. If you check the type of height, again the output you will be seeing or getting is int. So this is how you would coerce existing object to a new data type. We have coerced some of the data type. Example, we have done a height, but not all types of coercion is possible. For instance, if I would like to convert the contributor name, that is divgeorge, to an integer or a float, I will be getting an error. So the value which is enclosed between quotes, if it is a float or an integer type, then such types of coercion will be possible. However, if it is a string or a set of characters, then those types of coercion would not be possible. Due to shortage of time, I have limited the contents to be told in this session, but you can find more in python.org. So now let's look on to importing data. So before importing, you have to load or import necessary libraries. The first library being OS. In order to import any library, we use the command import followed by the library name. So we import OS library to change the working directory. There might be cases where you want to work with some data. In that case, you can basically change your working directory to whatever you have saved your data. So that is why we have imported the OS library, and then we are importing the pandas library. So basically we input pandas library to work with the data frames. Whenever we read any data, that becomes a data frame. That is what we call it as a data frame, where the data frames being represented in terms of a tabular fashioned data, where each row will be represented as a sample and each column will be represented as a so variable. So that is why we are importing the pandas library as PD. So here PD is just analyzed to find out. So whatever I want to access any function from the pandas library, I can just use PD with the dot operator. I can use the other related functions. So that is why I have used pandas as PD. Next, we have imported the OS library. So using the OS library, you are using the dot operator, and I am using the function called chdar, which stands for changing directory. And inside the function, you just need to give the path of your file, whatever it is lying on your drive or in your system. Now let us see how to read a CSV file. So read CSV is a command that is used to read any CSV file, and that comes from the package called pandas. I have used pd.readcsv. Inside the function, you just need to give the file name, and the file name being iris data sample. And I have given the file name with the extension .csv, and I have also given the file name within the single quote. So these two things are very mandatory to read any file. One is the extension and other is the single or double quotes. The other is enclosing the file name inside the single or double quotes, and if you see whatever I am reading, I am saving it into the object called data CSV. Now data CSV becomes a data frame whenever you execute this line, and whenever you read any data, all the blank cells will be read as nan, because there might be cases where you have some missing values in your data as a blank value. So in that case, Python will be default all the blank values to nan or nan, so that whenever you are going to use any function which is going to describe how many missing values are there in your record, and then the nan will account for that. So this is just a screenshot of the data whenever you open it from a variable explorer. So you have so many variables here, starting from index to species, and index being represented as the row labels starting from 0 to 4. Here the snippet. You have another column called unnamed column 0, where the values are starting from 1 to 5. If you feel this represents an ID to each of the rows, then you can keep this column unwanted 0, because you want too many columns which may have the same information to it. I just want to keep the unnamed 0 column, and I want to get rid of the index column, so that I have some IDs to each of the observation that can be useful for the future analysis. So let us see how to remove the unwanted column. So if you want to remove the extra ID column, you can pass an argument called index call is equal to 0 whenever you read a data frame. So let us see how to do that. So I have used the same command called pd.readcsv inside the function. I have given the file name, followed by that I have given the another argument called index column is equal to 0. That means that I am making any first column as index column. In that case, my index column would go, and whatever I had it in the name of unnamed 0, that becomes the index column here. So now you have 6 variables, where the first variable represents the serial number or ID for each and every record in your data frame iris data sample. So this is how we read a CSV file. This is how we also get your index column, by specifying the column number here. So here you can see there are some missing values, but I have mentioned that all the blank values will only be replaced with an and, because in Python by default all the blank values will only be replaced with an ands, not other special characters. But if you are sure that these special characters are just represents the missing values in your data, then if you want to consider them as a nan, you can also do that. And you can also replace these two question marks, hash as a missing values. So let us see how to do that. If you see, all the junk values can be converted to missing values by passing them as a list to parameter na values. So this is also be done whenever you read a data frame. So we are following the same command followed by the index call argument. You have to just give na values equal to a character, which should be enclosed inside the square bracket that represents it in a list. So I have given question mark here that should be given inside the single or double quotes. Then it takes it as a character and it will check those characters in that data. And if there are any question marks in the data frame, then it defaults that question marks to NaN values. So this is what we want to do now. So I have included NA values, arguments, and inside the square bracket I have just given the question marks. So once I read this, I will be able to get rid of all the question marks, and that will be converted as a NaN values. Say, but in our case, there are many special characters that are representing the missing values. So I can just give multiple values inside the square brackets. So that all these values will be read as a NaN. So here I have just added the hash by using a comma. So all the values will be read as a NaN. They can be treated also as a list, and it will check for those two values and will replace all these special characters with a NaN value. We have now discussed earlier about reading CSV files, that is comma separated value files. Now let's look on how to read Excel spreadsheets using Pandas library. So now this is how we replace all those special characters which represents your missing values into NaN. So we use read Excel _Excel is a command to read any Excel sheet in that, and that also comes from the Pandas library. That is why we have used pd.read _Excel inside the function, and I have just given the file name with the extension .xlsx. So here the same file, and I am using the different formats. So the extension being .xlsx here, and if you are dealing with Excel spreadsheets, then there might be cases where you might have multiple tabs, and the tabs being different with the different tab names. In that case, if you want to access data from a separate tab, then you give the sheet name under the sheet name argument. So here iris data is the sheet name from which I want to access the data frame. So I have given iris _data saved into an object called data _xlsx. Now this becomes a data frame. So there's a snippet from which you could get your spreadsheet name. So in your Excel sheet you will have sheet names. So you can just give the sheet name under the sheet name name argument. Now let's see how to get attributes of data. Attributes in a sense, getting the basic information out of data. So one such is data frame dot its columns. So on the right side you can see there will be data frame dot columns. This data frame dot columns will give you the column names of data frame. So you can get the column labels of the data frame using dot columns. So cars _ data1 dot columns will give you all the column names of your data frame. Basically the output is just an object which is a list of all the column names from the data frame cars _ data1. By getting the attribute of data like rows labels and column labels, you will be able to know from which range your row labels are starting from, and what are the column names that you have in your data frame. Now before moving to size, let's look on shape. So cast _ data1 dot shape will give you how many rows are there and how many columns are there explicitly. The first value represents rows, that is 1436 rows are there and 10 columns are there. So you will be able to get the total number of elements as well as how many rows, how many number of rows and how many number of columns are there separately. Now look at the data frame dot size. Data frame dot size gives the total number of elements from the data frame using the command dot size. Here it is just a multiplication of 1436 into 10. where 1436 are the rows and 10 columns are there. So when you multiply that, you will get the total number of elements. That is what the output represents. So you can also get the shape or dimensionality of data frames using the command dot shape. So here when we print cars underscore data 1 dot size, it shows that the the size of the data frame is 14,360. Now we are about to look at the basic data type that we are going to often work with. So now let's it is time to check the data type of each object or the data frame that we are working with. So basically, if you want to check the data type of each column, because whenever you have been given a data, you want to really check that what is the structure of the data, that means which variable has which data type. In that case, you can use D types, because that returns a series with the data type of each column, and the syntax would be you use D types or along with data frame name. So data frame dot D types will give you a series with the data types of each column. So the input would be cars underscore data 1 dot D types, where cars underscore data 1 is data frame, and that we are looking at, and the output is shown below, where you have multiple variables. Correspondingly, you have the data type of each variables. When we look at the first variable, that is price, the price taken, so the price data type is integer 64, which is the desired one, and the age of being float 64, and the kilometer has been added as an object. Similarly, you will be able to check the data type of each variable using D type commands. Now let's look on what is there's also given called info. So info basically there's returns a concise summary of a data type. Data frame. So concise summary includes data types of index, index being a row label. Data type of row labels is what output given as a as it gives the data type of column. It also gives the column of non-null values. So basically, how many field values are there in your data frame? All this contents or data or information is given by the command dot info. So it also gives a memory usage of the data frame, and the syntax would be use info command along with the data frame name. This is the end of the first part of the data science session. If you have any doubts or queries, you may contact me through my mail. Thank you.